Thanks to everybody who's sticking around. I know this is late, and I'll try to do a good job capturing your attention at this wee hours of the night. I'm from New York, and I'm from the Livepeer core team. And my goal today is to tell you a little bit about what Livepeer is and why we're building this in the first place. So what I will cover is to give you an overview of the project, to do a quick demo to show you how it works, and I'll tell you a little bit about why we're building Livepeer as a decentralized utility marketplace, and how that marketplace what kind of dynamic is involved in this type of marketplace, and how different types of people can participate in this marketplace. Before I get into the presentation, the Livepeer network, we've been working on that for about 2 years, and it's currently running on the Ethereum network mainnet. It's been running since March, and we've learned a lot of really great lessons since March, and we've been doing a lot of research. So a part of this presentation is created by some of the results in the research that we've been doing for the past seven months. So before I get into telling you about Livepeer, I have to tell you first about how video works on the internet today, right? Because Livepeer's goal is to replace a part of how video is working on the internet today in order to create scalability and affordability for all video infrastructure. So the way video works today is that we usually have a broadcaster that's sending a video stream into the cloud, right? So say maybe my phone, my camera, or a webcam, or this high quality video camera, and it's sending a video in the format of RTMP, which is just a video streaming protocol, and that's sending the video into a hosted media server in the cloud somewhere. And this media server is kind of the linchpin of this whole equation, right? So a media server is not dissimilar to a web server, right? And a web server is basically serving web pages to people who are requesting for it, and the media server basically serves videos for people who are requesting videos. And the media servers, one of the really important jobs for the media server is to transcode and encode the incoming video stream into many different bit rates and formats and video codecs, so that everybody who's connected to the internet can watch those videos, right? So if a video is coming in from that camera, somebody is walking outside with a cell phone connection who wants to watch a live stream versus somebody who is sitting at home with a high-speed internet connection can all watch that same stream. But in fact, they're actually watching different streams that are just being processed and transcoded via this media server. And the media server, of course, can also apply DRM on top of the video to preserve the privacy. We can store the video for later. We can ingest the video into a content delivery network so that the video can be multiplied into many different copies and delivered to the edge of the internet, so that everybody from all over the world can watch these videos, right? And while this picture looks good, there are some interesting facts about this. One is that the traffic of video on the internet is growing exponentially, right? Today, we already have over 70% of all the traffic on the internet in video format. So that's the two red boxes, right? And Cisco published this paper that in 2021, there'll be over 80% of all the traffic on the internet that's in the form of video. And this presents a big challenge, right? Because back here, this infrastructure is actually super, super expensive and really costly. To give you some numbers, it costs around $3 per hour per stream to do the transcoding for a single stream of video, right? Imagine if you are a large video platform like Twitch or Facebook or something like that, at any given time, Twitch has over 50,000 videos coming into their infrastructure, and just that they have to spend millions of dollars a month just to keep the infrastructure running. And on top of that, the content delivery network costs around $1 per user per month, right? So even if you have just 1 million users, which is a very modest number in terms of the scale of a video platform, now all of a sudden you have to pay millions of dollars a month just to be delivering your video. And that, plus the exponential growth of the video of the video traffic on the internet, presents this problem of like, how can we, as the internet, scale to the next level where we can meet this growing traffic and not break the bank while on our way there, right? And the solution for Livepeer is that in its current state, Livepeer completely replaces the media server and it replaces the media server with a decentralized network that provides the exact same interface to all the other components in this picture, but instead of having a SaaS company hosted media service, we will have a decentralized network that does the video transcoding for you. And this network is going to share resources and is going to drive the price down. So I'm going to talk about how that actually happens. But before that, let me just show you a quick demo of how this works. All right, so what I'm doing is I am bringing up my Livepeer nodes here, and I am bringing up a broadcasting software that's generally used by streamers like Twitch, and I'm starting to stream into my node. And what we see here is it's creating an Ethereum transaction, and it's kind of processing the network. So it's processing the video, and we can see here. And what I can do now is we can start to see the video being transcoded into different formats at different bit rates, right? So the large one may be going directly to my computer. The really small one may be going to my phone, and the medium-sized one may be going to a tablet or something like that, right? So that's the demo. Just close this. So what we saw is Livepeer kind of working in a single player mode, right? Like all the nodes are running on my computer. It's running against my local Ethereum network that I'm running in my computer. And the reason for that is I don't trust Wi-Fi's when I'm doing demos, so I always run it on my local. But in fact, there's already a peer-to-peer network deployed out there that can do this work for you in real time, right? So now that we see kind of how this works, right? Let's talk about how we can use this as a decentralized peer-to-peer network marketplace to create a super scalable and affordable network that's way better than the current status quo, right? And our goal here is to be much better than the current cloud service providers in terms of providing video infrastructure. So how do we actually achieve that? Well, so one goal we have is we want to have a dynamically scaling network that has a demand-driven pricing, right? So what does that mean? It means now if I sign on to Amazon, I will pay Amazon $3 per hour per stream to transcode my video, right? And that's the price is kind of fixed. It doesn't matter how much demand there is for Amazon to do the work. It's always going to cost me $3 per hour per stream. But in a decentralized network with the open marketplace, all of a sudden this dynamic changes, right? And what we can do is to have the market decide on the price for the video transcoding and for people to pay for that exact price. And the nice thing here is in just using basic supply and demand, when there's a lot of demand in the market, the price goes up and more supply comes into the market, and that makes this whole infrastructure dynamically scalable, depending on the demand of the network, right? And something else we do here is we do this thing called transcoding pools. And this is one of the ways for us to be able to scale building on top of the Ethereum mainnet today. And the way this works is instead of having all the nodes that have to exist on chain, every node that exists on chain can actually have thousands of nodes work behind them, right? And this is actually not dissimilar to like a private mining pool, where for Bitcoin or Ethereum, where you can have thousands of workers working for the same identity, and therefore creating basically infinite scale, horizontal scale for a transcoding network like this. And of course, so now think about, okay, we have the ability to potentially bring on thousands and thousands of machines on this network and have them work for other people. But how do we actually make this cheap, right? So open market is nice, there's price competition, that's nice. And another interesting thing here is that you can actually, for every single GPU, you can actually do video transcoding and cryptocurrency mining at the same time. So what I'm showing here is a modern architecture of an NVIDIA GPU card. At the bottom, these are the CUDA cores, and what they're used for processing, right? So there are tons of CUDA cores on there, similar to a CPU, but on GPU there's hundreds, and they're all used in parallel in order to do hash calculation for something like ETH hash for Ethereum, for example. But at the same time, on each one of these cards, there are video encoding chips and there are video decoding chips that are basically ASICs that can only do video work, right? The only thing that they can do is encrypting video and decrypting video. And in fact, the millions of video cards out there doing cryptocurrency mining right now are not utilizing those chips. Those chips are just sitting there doing nothing, right? And we have done benchmarks that shows you can actually do cryptocurrency mining and video transcoding at the same time on the same card without affecting the performance of the cryptocurrency mining. In fact, the only thing that you affect is you spend about 10 to 15% more electricity when you're operating both at the same time. So let's think about whether it makes sense for people to spend 15% more electricity to get this second revenue stream that comes in. Right. Well, it turns out that if you are a GPU card that runs in the AWS cloud, and if you're charging $3 per hour per stream, and let's say if you can utilize 100% of that GPU, Amazon is making $144 a day on that one single GPU card. And comparing that to a cryptocurrency miner who makes 75 cents a day on a single GPU card, there is a huge margin for all the GPU miners out there to be able to compete in price. And this is the margin that enables a 10x price reduction in the same type of video transcoding service that's available in the current transcoding cloud out there right now. So, and another interesting side effects here, of course, is using the public ledger, using the public blockchain. It comes with a lot of transaction overhead, right? So every single transaction costs money, and especially in a protocol like this, that transaction fee fluctuates over time. So what you don't want to do is to have the fluctuating Bitcoin or Ethereum transaction costs to all of a sudden halt your entire network, right? So for this, we've been doing some research on off-chain payment methods, and we've been we're leaning towards using this mechanism called probabilistic micropayments, which is a really simple way to enable off-chain transactions without incurring a lot of cost for the service provider. But the caveat for here is that this payment mechanism works really well for one-directional payment. So if you have a situation where where two parties, A is always paying B and B is never paying A, then this is a really good solution for that type of micropayment mechanism. And the goal here is to make the payment overhead to be less than 5% of the entire payment value, right? So, and that's pretty good even for like real world, credit card fee standard, right? So, so we talked a little bit about the technical capabilities and how we're able to actually create this network from a technical level and drive down the cost. But what about participation, right? A network only works when people actually participate and people actually take the incentive. And the goal here is really social scalability, right? So, and this is a concept that kind of says, each one of us as a person only has so much bandwidth to interact with people, right? So, and that kind of limits our ability to be able to work with people. And for example, creating a company and scaling a company is notoriously difficult because of this reason, right? People have social scalability limitations. And even when you're scaling a company under that structure, you start to run into a lot of side effects as these companies grow. The incentives start to be misaligned from the participants and the employees and the owners of the businesses, and it's really hard to create a structure in that environment that aligns all the interests from all the participants. But now we have blockchain, right? We have this open network. We have a token that can enable an ecosystem, and this is really important because this token kind of bonds everybody together. It aligns everyone's incentive, and it creates an opportunity for all different types of participants to be able to provide value and to be able to capture value. And they can do this in a decentralized way, which means they are no longer limited by the social scalability problem, by the Dunbar number, right? We don't need to we don't need to be collaborating with each other very, very closely in order to make this whole ecosystem work. This whole ecosystem is self-aligning the incentives for all the participants. So let's see in a simple example how this works, right? So this is simply this is on a high level how value flows in the Livepeer ecosystem. We have the Livepeer protocol that's creating rewards in the form of inflation, and the inflation is being paid to the active transcoders that are in the network. Now, these active transcoders can only become active if they get enough delegates to vote for them, right? And the delegates are basically token holders. So if I hold some token, I am able to delegate my token toward a transcoder or multiple transcoders who I think can do a good job for this network. And the transcoders in turn make the inflation reward based on the amount of votes, based on the amount of tokens that they get delegated to, and they also make the fees for doing the transcoding work for broadcasters, right? And in return for the votes, they pay a percentage of the rewards and the fees they make back to the token holders. Right, so this is kind of a self-contained ecosystem of value transferring that makes the token holders happy because they're kind of getting some rewards, but they're also doing the important job for the network, which is curating which transcoder is doing good work, so that when the transcoder is not doing good work, they very quickly fall out of the active set, and at the same time the transcoders are making money and they're all happy, right? But what about you are a application developer? Where do you fit in this ecosystem? How can you capture value? How can you create value, right? Well, one thing you can do is you can create, you're an application developer, you're good at creating applications. So you can create a application that allows, that helps the token holders to better make their delegation decisions, right? So maybe you can build a portfolio management tool for Livepeer transcoders, and you can build prediction models to figure out, oh, this transcoder is actually going to give you more return in the long term than that transcoder, but and also depending on your risk profile, it might give you this different suggestions. And now it's good that you build this application. The application is obviously useful for this ecosystem, but by building this application, you actually have an unfair advantage of reputation in this ecosystem, right? So now you're the builder of this application. You can now use this fact to start campaigning and to get people to delegate their tokens toward you, because you at the same time can also become a transcoder, right? So now, as you are participating in this whole ecosystem, you are being rewarded by the Livepeer protocol in the form of inflation. Now, this is a really interesting effect, because it's essentially the protocol is essentially saying, I will reward people who provide value to the ecosystem in the form of inflation, right? And this is a type of inflation funding that we're starting to see. We have started to see in the past 7 months in our network from being live on the Ethereum main chain. This is an example. This is a product called Supermax. And Supermax is basically a block explorer for the Livepeer network, for the Livepeer protocol. If you're a token holder, you can go onto Supermax and figure out, oh, how much inflation is currently in the protocol today, and if I wanted to delegate my token toward somebody, how much can I expect in return for the rewards and the fees that they're sharing back to me? And you can basically find out anything that ever happens in the Livepeer protocol. And Supermax also runs a Livepeer transcoding nodes, and in return they get inflation from the Livepeer protocol to fund the development of Supermax, which is a tool for the Livepeer protocol. Right, and now, because they have Livepeer tokens, they have an incentive to make the tool as good as possible, so that they can add more value into the network, and so you start to see this type of virtuous cycle that kicks off. Another interesting example is Chainflow. Chainflow is a project operated by the Aragon team. And Aragon is a decentralized autonomous organization project focused on creating DAOs, right? And this team is is doing a research project on creating a DAO-based transcoder. So instead of one person operating a transcoding node, it's the entire DAO that's operating a transcoding node. And of course, this is a really cool idea and a really important project in our ecosystem, because we want Livepeer to be a completely we want Livepeer to be more and more decentralized, as decentralized as possible. And of course, we don't, like Livepeer as a core developer, don't have the bandwidth to do this type of research, because it's not related to decentralized video. But this is a great way to fund research like this, because Chainflow also runs a transcoding node, and they also get inflation from the Livepeer protocol, and they use that protocol in order to provide more decentralization into the Livepeer protocol. And here's another example. It's a team called Bison Trails, and what they do is they specialize in running decentralized infrastructure in a scalable way. So they have open sourced many of their projects. They've helped people run mining nodes during the token distribution period for Livepeer, and they have also opened open sourced tools for helping people monitor their Livepeer nodes, so that if the nodes go down, they can be alerted and bring them back up. And there are some other examples as well. So those are just the technology examples. There are people. In fact, during DevCon last week, all of the breakout sessions were streamed on Livepeer, and that was done by an active community member who happened to be also connected to the Ethereum Foundation, and he got them to agree to film all the breakout sessions on the Livepeer network, and he coordinated all the filming, and all of that just happened in this decentralized way. And of course, he wanted to do that because he was a token holder, and he wanted Livepeer to do well, and he wanted to provide value to the ecosystem.
What kind of users do you have? How many users were watching it? Viewers?
Yeah, so I think during DevCon we had over 1,000 people every day watching those streams, and we had close to 1,000 hours of video streamed on the network. right? And an interesting distinction I want to make here is that Livepeer in its current form is an infrastructure project, right? So there can be any number of applications to be built on top of the Livepeer network. So when we talk about users, usually that's an application level concept versus on the infrastructure we usually talk about like the number of hours of video processed or something like that, right? Okay, so that's actually a good segue to thinking about the future and thinking about what this what this infrastructure can enable, right? So now we have this decentralized infrastructure that's more scalable and much cheaper than the centralized solution. What can we actually build with this? Well, one thing is this infrastructure will continue to grow to cover the entire video stack. Right, and that's interesting because like we showed earlier, the video stack it's not just about transcoding, right? It's also about delivering the video. It's also about encrypting the video. It's about playing the video. All of the software that's needed to make this whole stack happen. Currently, there aren't a lot of great open source software out there for this space. And it's from a variety of different reasons, but it just happens that, especially for the video technology space, there's not a lot of great open source software. But Livepeer as a protocol and as an open source ecosystem can drive this type of breakthrough. There can be an open source ecosystem that forms around Livepeer to create an entire open source stack. And in the blockchain world, there's a distinction when we talk about open source, because now it's not just code that you can run, it's the code that's already running that you can just start using, right? And that's a big difference because everybody knows MySQL is open source, right? But not everybody is able to run MySQL and maintain it and make it really make it really reliable. That's why companies form to run these open source software, right? But with this blockchain, with this network, it's already running on the network. The network is already running. Every new piece of open source software all of a sudden automatically becomes deployed in its deployed form, and it's readily usable for users. And that's a really powerful concept. Another thing that it can happen is it will continue to push the cost of video infrastructure down. And we think it's going to push it down. It's going to approach the cost of electricity, which is the true cost for providing these types of infrastructures. And if we think, okay, the cost of video infrastructure is actually the cost of electricity, we will start to get into the realm of treating video infrastructure as a true commons, right? As something that can truly be shared as a commodity for everybody who's connected to the internet, not dissimilar to everybody's sharing the roads that they drive on or sharing the air that they breathe, right? And what kind of content can we produce in this world where video infrastructure is truly a commodity? Well, one example I always give people is there are great universities around the world, and all of those lectures are a big number of those lecture halls already have cameras built. So why aren't we streaming all the lectures from all universities all the time? Well, it's because universities can't afford it. It's expensive to deliver those videos. So now when we have these types of really cheap infrastructure, we can also imagine there's going to be so many types of new video content never seen before now readily available for people around the world to watch, and that's and that's also really powerful. And finally, as we see this ecosystem grow, we expect to see a lot of the components become professionalized. So there will be many businesses built on top of Livepeer. May it be SaaS businesses that take advantage of the big price differentiation. Or it could be different types of decentralized applications that are built on top of these decentralized networks. For example, these networks offer you censorship resistance. They offer you they offer you the ability to use true micropayments so that you can have you can create all different types of business models with your new viewers now, instead of just using an advertising-based business model. So these are all some interesting examples. So that's my time. Thank you guys all for sticking around. This is, and I'll answer questions.